Okay, so before we start the notes, let's make sure of a very important concept that comes up within inequalities that is not involved within equations, and that is when we multiply or divide by a negative. So when we multiply or divide by a negative number, we flip the sign, the inequality sign. Why do we do that? Well, let's use a basic example. Let's say if we have an inequality 8 is greater than 4, which is a true inequality expression. Well, let's say we multiply by -2. What we do to one side, we do to the other to keep the inequality equivalent, quote unquote. When you do -2 times 8, sorry, I'm going to keep that in. Never mind. Sorry, still getting used to this program. We're just going to keep it in black there. -16. When we do -2 times 8, and 4 times -2 gives us -8. So ask yourself, -16. What is -16 relative to -8? It is less than. So if you see when we multiply by negative on both sides, the inequality sign flipped. So to keep the the inequality quote unquote equivalent, we have to flip the equality sign when we multiply by negative. Similarly, if we pick two other numbers, 6 and 3, 6 is greater than 3, and let's say we divide by some number. It really doesn't matter what number we divide by. I'm just picking nice easy ones, but we're trying to illustrate the principle here. So I divided by -2. Actually, let's go ahead and let's do some easier numbers. Let's divide by -3 instead. Divide by -3. If we divide by -3, that would give us -2 and -1. So ask yourself, what is greater, -2 or -1? Well, -2 is less than -1, or -1 is less, or is greater than -2, excuse me. So therefore, when we divide by a negative, we see to keep the inequality correct, or to keep it quote-unquote equivalent, we flip the inequality sign. So let's keep that in mind as we move forward with our lesson. Okay, so on your review, we'll skip the notes and go specifically to the examples as you did the notes in class. When we are looking for x, first we simply solve for x. How do we solve for x? Well, we get x by itself, whatever's furthest away from x, which on the left-hand side, which is -4. We add 4 to both sides, which these cancel, will now give us 7x is, excuse me, 7x is greater than 14. We divide by 7, and 7's cancel. We divide it by a positive. Positives we don't flip. We could prove that if we wanted, using the same examples that we did before, except dividing or multiplying by a positive, and we'd see that the sign wouldn't flip to keep it equivalent. Okay, so we get the solution, this inequality, all values for x greater than 2. So we label 2 on the number line. If your teacher prefers you label more, then go ahead and do so. Since it's greater than, it's an open circle, which means 2 is not a solution, and then all values greater than 2. So think about if you pick a number on, for instance, the right-hand side, like if this is 4, if I plug 4 in, 4 is greater than 2, therefore it's a solution. Therefore, all of these are solutions, as we did within the last section. Okay. Moving on to number 2, same thing, we are solving for x, so we go ahead and subtract 16 from both sides. These cancel. We now have -5x. Note the 16 moved over when we subtracted. The -5x was not affected, so you keep the negative in front of the 5. And then -19 minus 16 is -35. We now divide by -5. Note, we divided by a negative number, so to have the correct inequality sign, we have to flip it from a greater than or equal to or less than or equal to. -35 divided by -5 is +7. So we put 7 on the number line. X is less than or equal to, therefore 7 is the solution, and therefore we have a closed circle. Then we pick a number on the number line, and if it's true, we shade towards it. If it's not true, we shade away from it. So for instance, I'm going to pick 10. If I plug 10 in for there, this is what it would look like. 10 less than or equal to 7. That is not true, therefore I do not shade towards 10. I shade in the other direction, and therefore there is our solution. Next we have number 1 on example 2. This is exactly the same as what we did before in terms of solving. The only challenge now is a little more challenging as far as solving. First we have to distribute. So we have 10 minus 6x when we do negative 2 times 3x minus 8 less than 11. And I apologize. Let me go back on that. Okay, if you look, I corrected my mistake. When you distribute the negative 2, you get negative 6x, negative 2 times 3x, and then negative 2 also multiplied by 4 gives you negative 8. Nothing else was affected. Now, if we look at what we have here on the left-hand side of the equal sign, I will outline it in blue. That is an expression with an x in it and constants. We want to keep the x there and combine the constants. Note it's an expression, so we combine like terms. We don't add 8 or subtract 10 from both terms. We think of it as 10 minus 8, as it is. 10 minus 8 gives us 2. And that is still less than 11, as we did nothing to the right-hand side of the inequality. And now we solve. We subtract 2 from both sides. Cancels. We now have negative 6x less than 9. Less than 9. And then we divide by negative 6 on both sides. Note that is a positive 9 right there. And now the negatives cancel. Note we divided by a negative, which means the inequality sign flips. There's a positive 9 over negative 6, which I then move the negative to the numerator. Why? It's just the preferred form. Now we want to reduce that fraction, which will give us negative 3 over 2. I apologize for not using my room as nicely as possible. So therefore we have negative 3 over 2. Now with non-whole numbers with integers, I prefer that my students put negative 3 over 2 as a decimal, which is negative 1.5. I prefer they put it between the two whole numbers. The two whole numbers at negative 1.5 is negative 1 and negative 2. And where is that? It is right between them, and since you can put the mark, the goal is to put it right in the center. Kind of difficult doing it as I am on the iPad. But in any case, we want a marker halfway between them in an open circle. The open circle is because it is a greater than inequality, not a less than. Note, greater than values will be the solution. You could also pick a value like negative 1, plug it in. Negative 1 is greater than negative 3/2, so therefore we shade towards negative 1, and there is our solution. Next we have number 2. We want to solve for x. So we do the same as we have done in the past. Solve for x, add 2 to both sides. Note, when we're adding 2, we have a problem or challenge relative more than what we're used to. 5 is our denominator, so we want to write 2 as a fraction with 5 as our denominator. So if our denominator is 5, what would our numerator have to be in order for it to be 2? It would be 10 over 5. Note the procedure for that I'll do over on the side. If you want to get it, if you have 2 over 1, which is 2, and you want to get a denominator of 5, you multiply by 5 over 5 to get a denominator of 5, but you also multiply by 5 over 5 because that's a value of 1. It doesn't change a fraction. Note that's supposed to be a 1. So that gives you 10 over 5. Back to the equation. We have 3/8 x. The 2's cancel. We have 1/5 plus 10/5. So if we have one of them plus 10 of them, we get 11/5. Okay, so now we want to solve for x. We're multiplying by the fraction 3/8. Instead of dividing by 3/8, it's preferable to do the most efficient. When we're dealing with fractions as coefficients, we multiply by the reciprocal. Those cancel. We have x here. Note we multiply by a positive number. So therefore the sign does not flip. On the right hand side we want to look if we can cross cancel. There is no canceling, so we have 11 times 8 is 88 over 15 is our Solution. If you put 88 over 15 into your calculator, you get 5 and some decimal, 5.86 repeating, which means 88 over 15 is somewhere between 5 and 6. So we put 5 on the number line, 6 on the number line. Note, if you want to use the markers a little differently, you put 5 here, for instance, and 6 here. That just gives you more spacing based on the scale you use. And then you want to put the circle accordingly. So actually, let's go ahead and do it that way. Let's go ahead and get rid of that. And I'm going to put the 5 here. Oops, let's do this in black. I'll put the 5 here and the 6 here. And 0.86 is going to be closer to 6. Note, it's not at 6. It's supposed to be an open circle. As again, it's hard for me on the iPad to do it, the tedious writing. So in any case, 0.86 is a little closer to 6, and x is less than that. So if we plug in values that are less than that, that would make it true. We shade in that direction. Okay, now we're working on word problems. These are very similar to the equation word problems that we've done, but now we're talking about meeting at least so much, or at most, and so forth. And at most or at least, greater than, is less than, is dealing with inequality. So let's first pull out the math information. He has accepted a job selling cell phones. If you go to the question for what amount of sales, that will give you your variable. So x, or whatever variable is the amount of sales, I'm simply going to write sales. He paid $1,500 plus 15%. He will be paid, $1,500, so he has a base salary of $1,500 plus his what we call commissions, which is 0.15 of, note, x is his monthly sales, so we do 0.15 times x, note 0.15 is the decimal form of the percent, times a variable, the amount of sales, and he needs to earn at least $24.30. So, let me give myself a little room here. This over here, I'll box it in, this side of, or that expression represents how much he's making. We want that to be at least, so that amount or equal to, greater than or equal to the amount of $23.30. And there is your equation. So we have 1,500 plus 0.15x is greater than or equal to. We need that to be the same as 24.30 or greater than, and therefore there's our equation. Okay, so let's go ahead and write it a little nicer. Sorry. Let's go ahead and get rid of that. Okay, let's write it a little nicer. 1,500 plus 0.15x is greater than or equal to 23.40, and now we go ahead and solve that. So we have x is right there. We get rid of what is furthest from x on the left hand side, which is subtracting 1,500. So now we have 0.15x equals what, 760? Or 860, excuse me. So we have 860, and now we divide by 0.15. If you plug that into your calculator, you get x, whoops, I apologize, back at this step, that was supposed to be a greater than symbol. X gets you greater than 5,733.3 repeating, which will just make 33 cents. So what this is saying is, for what sales, amount of sales, will he be able to pay his bills? So if he has a base salary of $1,500, you know he makes 15%, he sets up this inequality and solves for x, he knows he's going to have to sell at least 5733.33 sales in order to pay his bills accurately. Okay, problem number 2. We want to pull out the math information. It may certainly help to read the question first. What are the number of plants that she can purchase? So number of plants is our variable. So let's go and write that. X equals number of plants. Okay. So first off, she spent $23 and she purchased a t-shirt, $5 t-shirt, and now wants to buy some local plants for $2.50 a piece. We don't know how many she can buy, but I'm sorry, she brought $23. I go back to the beginning. She brought $23. So that's how much she has to spend on one side. Okay? She already spent $5, and we want to add $2.50 per plant, and that needs to be what? If she only has $23, she can't spend more than that. She has to spend less than that or equal to. So if we just say equal to, that's how many plants she can buy. It has to be less than or equal to. So keep in mind, number of plants, it's going to be a whole number. We'll see as we solve. Okay, so that would be the setup. She has $5 she spends on a t-shirt plus the $2.50 per plant has to be less than or equal to 23. If we subtract 5 from both sides, let's go ahead and give myself a little room here. We now have 2.5x less than or equal to 18. When we subtract those, 2.5 times x, so therefore we divide by 2.5. And then that will give us x less than or equal to 7.2. Well, you can't buy 0.2 plants, so we round that down, so it has to be less than that. So the greatest she can buy, the number of plants that she could buy, is 7 plants. Number 3, we want to know how long can Patty stay ahead of Keith. So our variable is how long, which is time. We notice we have 2 people running. We have a distance between them, 15 feet. We also have a rate, 5 feet per second and 8 feet per second. And it also says how long. So if you look at all the variables that we have distance, we have rate, and time. If we're just talking about an object moving at some constant rate for some amount of time, we have the equation D equals RT. The question is, how long can she stay ahead of him? So now if he gives her a head start, there is a difference in their distance. The distance that Keith minus the distance of Patty, we want to know when that is less than or equal to 15. So how long can she stay would be equal to 15, but since we're in inequalities, we just do less than or equal to. You could set it equal to 15 as well. But in any case, if we have distance equals rate times time, that means the rate multiplied by the time is what Keith's distance is. If he is going 8 feet per second, that is his rate, and we don't know the time. That's what we want to find out. The time that it takes for him to catch up would be t, minus the rate of Patty is 5 feet per second, but that's the rate, and we don't know what the time is, so her distance is 5t. We want to know when that will be less than or equal to 15. Okay, now we go ahead and solve. Okay, I apologize for the pause. I thought it was paused as I was looking through this problem. Okay, so what we're doing is first look at the question for what number of minutes. So our variable is what number of minutes. So we can do X or whatever variable you prefer, number of minutes in terms of typing. I Apologize for the sloppiness of the writing. So we're comparing Sophia's to Patton's, where Sophia has more words than Patton's. So we can set up a general equation of Sophia's words per minute, words typed, is greater than Patton's. Well, let's look at what information we have for Sophia. Sophia, all we know is that she types 75 words a minute and is just starting to write. So she doesn't have any written. So words per minute is our ratio, multiplied by the number of minutes. X will give us how many words she has typed. And we want that greater than Patton's. So if we look at Patton's, we see Patton has 510 already typed and plus 60 words per minute. So there's our setup, and we want to know when will she have more, for what number of minutes will she have more words typed. While we go ahead and solve the equation. First we subtract 60 x, y, we want to get the x's all on one side. And since the 75x is by itself, we move the other term over. So when we subtract that over, we get 15x greater than, those cancel, 510. When we get that, we get x greater than 34. So for what number of minutes will Sophia have more words typed? For the first 34 minutes.